we call that left-hand rule, and how do one vector cross onto another vector, right? Remember your Fleming's left-hand rule, and then I teach you, look at this, and then use your other hand to decide whether it is which direction it goes. Can you remember? Okay, so that was the practical aspect of this, how to so-called visualize your cross product visually. Now I need to give you a definition. Okay, this definition somehow is not in your lecture notes. It's not official, so I want you to write down. Okay, the purpose of a cross product. Okay, so cross product produces a vector that is concurrently perpendicular to two other vectors. One more time, cross product produces a vector that is concurrently perpendicular to two other vectors. So that is the reason why I asked you to use your left-hand rule. One more time, cross product produces a vector that is concurrently perpendicular to two other vectors. Can write down already? So let's go back to your left-hand rule. Can you focus on your thumb and your index finger? Okay? Is your middle finger perpendicular to the index? Is your middle perpendicular to the index? Is your middle perpendicular to your thumb? Okay, so that is the reason why I use this. Okay, a cross product produces a vector that is concurrently perpendicular to two other vectors at the same time. Can you get? So if you don't like the thumb cross with middle, thumb cross with index, we can do thumb cross with middle. Thumb cross with middle, I'll produce your index. So look again, is your index finger perpendicular to your thumb? Index finger also perpendicular to your middle finger. Okay? Okay, so that's how you remember your cross product easily. And of course, remembering it is one thing. Don't forget the formula. The formula is A cross B, magnitude equals to magnitude A, magnitude B multiplied by sine theta. Very, very similar looking to your dot product or your cross scalar product, but okay, on the left that's magnitude. On the right it's not cosine, it is sine theta. Okay? Next item, same thing, this is your third set of properties. I reminded you, chapter 1, there's one set of properties. Chapter 2, there's another set of properties. This is your final set. 3.2, your properties pertaining to your cross product. So among all these properties, this is one of the most important one. I boxed up for you already. A cross B is not equals to B cross A. Okay, there's a difference in direction. If you can remember your left-hand rule, how I turn this way or turn that way, the thumb will switch direction. Okay? So A cross B equals to B cross A negative. Then, again, can you again please highlight this? Non-zero vectors. Okay, non-zero vectors. If I say that A is parallel to B, okay, when A is parallel to B, what's the angle between the two vectors? When vector is parallel to one another, it's either 0 or 180, right? What is sine 0? Sine 0 is 0. So what is A cross A? 0. Okay, so any same vector crossed together will be 0 because of the sine 0. Easy to remember, but sometimes you may get blur yourself. Can? Okay, so in particular, I cross I equals to J cross J equals to K cross K equals to 0 vector. Can? Okay, so this is the one that sometimes will create confusion. Okay, remember your left hand rule? I say that what? Index cross with thumb will give you middle finger, etc. Okay, so if you look at your three axes, x, y, and z, or I, j, k axis, I cross j is equals to k. Then j cross I will be equals to minus k. Can I accept? Just look across the first line. I cross j is k, j cross I is minus k. Can I accept? Can I accept? It's basically this. Can? They are perpendicular, right? Hang on, can you make a note to yourself? Whether is equals to k, when I say I cross j is equals to k, or when I say I cross j, can I make it equals to minus k? I can. It is a matter of convention. Okay? If you say that I cross j is k, automatically j cross I must be minus k. But if you prefer the other way around, j cross I is equals to k, I cross j equals to minus k, then j cross I is equals to k. Can. So what I'm trying to say here is, you decide on the convention, stick to one convention in your one whole question. You don't say part 1, I say I cross j equals to k. Then part 2, I cross j equals to minus k. Cannot. When you're doing a question, it's just like how I do a sketch. Everything is unknown. Everything is 3D. I'm just doing a sketch. So if you make a certain assumption, you stick to a certain convention, make sure that convention stick for the entire question. Okay? So this is not a hard and fast rule that I cross j must be equals to k. Not necessarily. Depends on your convention. Follow? Okay? So important thing is, remember that I cross j not equals to j cross I. Okay? And then this one can be confusing, because dot product, it is true. When I activate this associative law, it is true for dot product, but it is not true for cross product. So I cannot say that I cross j is equals to I cross I cross with I cross j. No such thing. Okay? It's no longer associative. So how do I prove to you immediately is, just look at ijk. I cross j will give me k, right? I cross k will give me minus j. Then if I do the other way around, I cross I actually is 0. Then cross with j is equal to 0. So your associative law don't apply. Okay, I cannot say I anyhow switch the bracket. No such thing. Okay, distributive law applies. Then if you have a scalar in front, you can always take out the scalar. So E and F, nothing fantastic, similar to your dot product, no big deal. Okay, this one, copy down the example first, and try to internalize, see if you can understand what the hell is happening. A cross with bracket 2a minus b. Distributive law says that is 6a cross a minus 3a cross b. Anyone with problem with the first line first? Let's settle line by line. Anyone with problem? Can you understand how I go from here to here? Okay? It's just distributive law. 3 times 2, I get a 6. A cross a stays. 3 crossover minus 3 times of a cross b. So far so good. So what happens to a cross a? Same vector, angle 0, sine 0. So it becomes 0. So write down is equal to 0, and that's how come I'm left with negative 3a cross b. Okay? And based on your properties, a cross b is negative of b cross a. So that's how I remove the negative sign. So far so good. So it's basically all your properties at work. Anyone confused? Anybody lost? Anyone confused? And please know your properties very, very well. Reminder one more time, you usually get 2 questions in the A-levels, 1 question with number, 1 question with no number. Okay, H. Can you please asterisk again? Okay, if, ever, this is always tested in exams. If I tell you A cross B is equals to 0, okay? If I tell you A cross B is equal to 0, it can infer, or rather you can infer 2 possibilities. Either A is a 0, or B is a 0. Then cross product will be 0. Or, they are parallel. A must be parallel to B. And then you also create a 0 cross product. Okay, so it's either this scenario or this scenario. Okay, can you please break it up? Because the or may actually confuse you. Okay, it's either this scenario or this scenario. Okay, so right now, as I said, I'm just pushing down the properties to you. When you actually do the questions, these properties will actually come back again and again. So for the time being, accept and be aware that these properties are around. Okay? Okay, I settled the first thing on your properties, on the properties already. So now the second aspect, how to deal with it numerically. What you see down here in your lecture notes is also available in your MF26. Okay, usually I hate this shit. I don't know what A1, B1, A2, B3, I hate it. Okay, so don't bother so much. Let me teach you how to do it quickly. Okay, so numerical example. I'm practicing you how to do cross product numerically. So focus on the first one. Okay, let's use this as a practice. A cross B. How I do it numerically. Take down first, then after that I'll go through how it happens. Next time, settle that before you come in, or else the lecture will just keep going on. Understand? Okay, ready? Okay, come, look. How to do cross product? Okay? 1, 2 minus 2, cross with 3, 0, 1. How I do the cross product is, how I get this thing is I cover the first row. This one times this one. Minus away. This one times this one. One more time, Cover the first row. Cover the first row. Cross it. 2 times 1. Minus away. Minus 2 times 0. That's how I get my 2 minus 0. Follow? How I get the second item? Cover the second row. Cross. So 1 times 1. Minus away. 3 times minus 2. Then put a negative on the outside. How I get the third row? Cover. 1 times 0 minus 3 times 2. That's how I get my 0 minus 6. So now you refer back to the generic formula on top. Okay, so this is what is happening. Okay, this is what is happening for those who happen to learn matrices in your secondary school. If your teachers have taught you matrices before, it is actually your matrix theory. Okay, but if you don't know all the shit, don't bother. Just remember how it works. Okay? Can I understand? Need to repeat? One more time, Okay. When you are doing a cross product, how to get this number is cover the first row. Then look at what is left. This one and this one. 2 times 1 minus away this one and this one. That's how I get my 2 minus 0. Second item, cover the middle row, cross. 1 times 1 minus away, negative 2 times 3. Then everything negative sign. Third one, third component, cross the third row. And cover the third row. Cross on top. 1 times 0 minus 3 times 2. Can? So, for lecture purposes, we do like that. Step by step for you. If you can do it mentally, go ahead and tell me 2 minus 7 minus 6 straight away. It is fine. Okay, you don't need to show me all the funny workings if you can go through it mentally. Okay? Okay, so this is how to do your cross product numerically. So coming back to the question, I need you to verify that the left hand side is equal to the right hand side. So what you see now is a mixture of dots and cross. So your rules of mathematics says that we deal with the bracket first. So let's focus on the left hand side. Left hand side, I found what is A cross B. Then what is A dot? A cross B. So your dot product comes back. A dot A cross B. Can remember your dot product process. 1 times 2 plus 2 times minus 7 plus minus 2 times minus 6. You get 0. So that is your left hand side. Okay, that will be your left hand side. Then similarly, you do it for the right hand side. B dot with A cross B. And then you prove that it is actually equals to 0. They are the same. You have verified your results. Okay, if you are done copying, focus on this little scroll that we have for you. Okay, during the exams, whenever you do cross product, please double check. Because your vectors question usually is a massive one. So usually it's going to be a 12-mark question, then part 1, part 2, part 3, all interlinked, all related. Okay, some of you really caught eye on, okay? You cross product, really cross until you don't know what, okay? So please double check, because the implication is if I ask you to do cross product in part 1 and you make some stupid careless mistake in part 1, part 2, part 3, part 4, part 5, everything implicated, you're going to lose a lot of marks. So cross product is always a point where the students somehow just make a lot of careless mistakes. Double check. Okay? Okay. Next example. Let's return back to your theory. What is the purpose of a cross product? A cross product produces a vector that's concurrently perpendicular to 2 other vectors at the same time. Do you know how to do this exercise already? I want to find a vector that's perpendicular to P and Q. So what you need to do is I need to cross P and Q. Can understand? Okay? So listen up. In the exams, or the setting of the question will be like this. Find a vector that's perpendicular to P and Q. To stop. I will not tell you by using cross product find a vector that's perpendicular to P and Q. They'll never say this shit to you. I just tell you find. So your theories, your concepts better come out. Then practice one more time. Come. Practice on your own. How to do the cross product. Cover on your own now, rather than copying my answers. Okay, practice. This is a skill that you guys must have. Okay, because the last thing that you should do is during the exam you refer to the formula list and try to figure out how to interpret that stupid formula on cross product. Okay, get it into your brain once and for all. Cover the first row, cross. Cover the second row, cross. Then add a negative. Cover the third row, cross. Try. Able to get minus 17 to minus 8. Okay, for those who are actually doing, you realize that somehow the careless mistake will start creeping in. Okay, so please double check during the exam itself. CT1 confirm have already. Okay, so please. The last thing that you should lose marks is over careless mistakes. Can? Okay, so as I said, this section of your solution, this whole chunk here, purely optional. If you can do it mentally, by all means, don't show me this. You give me this, it's enough for markers already. Can? Okay. This one, can you please asterisk? This is another example of a question that got no numbers. I just show you like that. If C is perpendicular to A and B, give me the relationship between A, B, C. Stop. Okay? So a question can be set like that. So there is no numbers. There's nothing for you to check. There's absolutely no workings at all. What you need to be activating is all your concepts, is all your properties. If C is perpendicular to A cross B, what can you infer? Okay, so basically all the diagram must start coming up. Okay, if C is perpendicular to A and B at the same time, where actually is C? So theory, cross product produces a vector that's concurrently perpendicular to two other vectors at the same time, right? So if C is perpendicular to both A and B, what it implies is that A cross B confirm parallel to C. Make sense? A cross B will be parallel to C. So that's what the question is asking you to infer. So you must tell me C is parallel to A cross B, and from your chapter 1, if they are parallel, C will be equal to lambda A cross B. So we are looking for this answer. Okay? So if your properties is 0 in your brain, there's nothing you can do for a question like that. Nothing. Absolutely nothing. It's just blank. No way you can write a single statement. Okay, so please start memorizing, start internalizing your properties. It won't work if you say that tomorrow is the exam, today I memorize the properties. Guarantee cannot work. You need to internalize other than memorizing it, because this is where you apply. Okay? Okay, let's move on. The second use, the first use of a cross product is to find a vector that is concurrently perpendicular to two other vectors at the same time. Second use of your cross product is to find the area of a triangle or to find the area of a parallelogram. Okay? How does that happen is, can you remember this formula? Half AB sine theta from the secondary school. To find the area of a triangle. Half AB sine theta. Look at your look at your cross product formula. Okay, your cross product formula look like this. Magnitude A, magnitude B, sine theta. This is your cross product formula. Does it look absolutely similar to your triangle formula? I add a half. Isn't that the triangle formula? Okay, so because of this, because of your cross product equation, the area of a triangle is actually just half of A cross B. Finish. So if I ask you, give me the area of triangle ABC, it is basically just half of AB cross AC. And then, what's the relationship between a triangle and a parallelogram? A parallelogram is 2 times of the same triangle, right? So the area of a parallelogram is AB cross AC long. Finish. Okay? AB cross. Okay, in this question they say AB cross AD. So far so good? So far so good? Okay, before I go any further, let me ask you now. Okay, can you look up onto the screen? This is not your lecture notes. Okay, to find the area of triangle ABC, I say half AB cross AC. Can I use half BA cross CA? Can or cannot? Can or cannot? Yeah, here I use half AB AC. Can I use BA CA? What do you learn in your chapter 2? I told you the rule is that make sure your arrowhead is all pointing out from the same point or all going to the same point, right? So in this case, both my arrowheads pointing out? They are. Can I make the arrowhead turn in? Can. So this is not the only possibility. I can change CA cross CA cross with DA. Can? Okay? So there are many permutations, many possibilities. Stick to the same rule. Arrow in or arrow out. Okay? Sometimes, actually it doesn't matter. But I just want you to stick to the same convention. Then you won't be confused. Okay? Then similarly, when it comes to the area of a parallelogram, here I use AB, AD. Can I use this instead? AB, AC. Cannot. Can I use AD cross AC instead? Think this way. Area of a parallelogram is twice the area of the same triangle. So instead of using AB cross AD, can I use AB cross AC? Can, right? It's just I'm using another triangle, right? Okay, so again, the possibilities are limitless. As long as you give me the area of two triangles, which triangle you want to use is your choice. Can? Okay, one example, numerical example to run you through. Okay, example 2a, question asks you for area of triangle ABC, and I give you position vector ABC in your IJK form. Okay, let's look at example A first. So same thing. Okay, your lecture notes are structured in such a way that left hand side is your solution, right hand side is your thought process. I want you to focus more on the right column, not too much on the left. Okay, so question wise, everything given in IJK. So I told you in your lecture notes, I say good practice to write in column vector form, because sometimes you already got I on all the I and J to make a mess for you. Write down everything sui in your column vector. Then I want area of triangle ABC. So what to do next? Okay, now your turn. Can you sketch for me? I purposely never sketch now. Can you sketch for me? Where is ABC? The rule of thumb when you're doing a sketch is draw a sketch to your advantage. Anyhow sketch, it doesn't matter one. Draw for me, where is ABC? Is O necessary? Is the position of O necessary? Actually, I don't even bother with having O. I can call this A, I can call this B, I can call this C. Up to you, no? You don't like this sketch, you go and sketch another diagram. You call another point ABC, you switch around with the position. It's absolutely fine, it's just a sketch. Okay? The sketch will then guide you what to do. I need to find the area of triangle ABC. So the rule of thumb that I always tell you is make sure the arrowhead is coming out or going towards the same point. So for lecture purposes, I'm going to use AB cross AC. So it's going to look like that. AB cross AC, right? Okay, so you don't have to change the diagram, no, just draw accordingly to what you have drawn on your own. So AB cross AC, half of its magnitude will give me my area of triangle. So what you need to do next? So what you need to do next is, if I know what is OA, what is OB, What is OC? Find AB and AC via your vectors addition and subtraction. Okay, so what is AB? AB is, from your chapter 1, OB minus OA. And similarly, AC is OC minus OA. Okay, so all these things I fast forward. I just give you the answer. So what to do next? Activate the formula. Formula, please know, half of magnitude AB cross AC. Okay, then you dump in the values for AB and AC. Okay, try again. See whether you can get me the numbers properly. Cover the first row, cross. Cover the second row, cross. Then follow with an extra negative sign. Cover the third row, cross. Okay, try, make sure you know how to do it numerically. Drive it into your brain once and for all. Okay, you should arrive with minus 10, 5, minus 10. Can? Okay, so by now you have a few practices already. If you are one of those unfortunate people who always make careless mistakes, you know what to look out for in the exam. Okay, then don't forget, your formula is A cross B magnitude on the outside. So what you need to do with this number? This number got the magnitude from your chapter 1. I need to find the magnitude of this thing. Okay, how to find the magnitude? Here what I did was I factored out 5. So it's actually 5 over 2 multiplied by 2 square plus 1 square plus 2 square to arrive at 15 over 2. Area of a triangle is a number, it's a scalar. So you cannot give me area as a vector. And area must be a number. So end of the day I should see this. I should not see something like that. I cannot be seeing something like that. That cannot be the area of a triangle. Okay, then of course in your right hand side column, instead of doing AB cross AC, I gave you a few other possibilities. But please don't ever go and do this. Half OA cross OB. What area does half OA cross OB give you? Area of what triangle? This one gives me area of triangle OA. Okay? So please don't make a start properly. So that's the reason why a sketch will always help you. Questions so far? Any questions? Next one. Okay, can you please read the question now? The question now asks you for the area of a parallelogram PQRS. But I only give you P, Q, and S. I never give you R. Okay? I give you the position vector of P, Q, and S, but I ask you for area of parallelogram PQRS. Okay? So, same thing, before you begin anything, just sketch first. Okay, please sketch. Okay, this one, please be careful. I think the convention, when it comes to diagrams with more than 3 vertices, you need to label your diagram in a continuous manner, either clockwise or anti-clockwise, your choice. So I've chosen to do PQRS in a clockwise manner, starting from P at the bottom. Okay, you don't say PQRS, don't anyhow jump. It must be continuous. either clockwise and anti-clockwise. Okay? Okay, so that's a little bit for your sketching. Next item, we are asking for the area of parallelogram PQRS, but R is missing. Is the position of R critical? Do I need R? Don't need, right? Because your theory says that area of parallelogram is twice the area of triangle. So I make use of available data. And then I find my parallelogram PQRS. So which triangle am I going to focus on? Because I'm going to P, Q, and S. So obviously I must focus on this triangle. Okay? So your job is to play with PQ cross PS. Okay, understand? So same thing, I write down everything in column vector form. I go and find what is PQ, what is PS. Thereafter, pull out the formula. Reminder, formula for area of triangle, formula for area of parallelogram, not inside formula list. You must be able to recall. So it's just PQ cross PS, then you have your answer. Okay, I leave it to you to handle the alternatives, but I want to go through some of the stuff that's wrong. What will possibly be wrong? What many people will do a lazy and they just do OP, OS. Confirm wrong. Okay, this one confirm wrong. Okay, this one I want to ask you. SP. OS. Correct or wrong? Look at the diagram. SP cross OS. Can or not? Also wrong. Okay? So this is exactly the reason why you must have a sketch. When you have a sketch, it will be very clear to you which are the points or which are the vectors you need to be crossing with one another. Okay? So these two confirm wrong. The various alternatives, I think by now you should be quite proficient. I leave it to you. Can? Okay. This is the jalat part. Can? Okay. Reminder, number one. Your cross product got two purposes so far. Number one, to find a vector that's concurrently to perpendicular to two other vectors. Number two, to find area of triangle, to find area of parallelogram. Number three, this is the part that is confusing. I can find a certain length. Okay? Look at this thing, I run through one time. Okay, if I say that CH is vector H, CA is vector A. Okay? So referencing to these 2 points and referencing to this diagram. Okay, I want to find the length of HP. Okay, I'm interested in this length. Follow? Okay, let's use trigo to help you now. What is the length of HP using trigo is sine theta is equals to HP length over CH length. Agreed? Trigo. Using trigo alone. Nothing new yet. Can? Okay. Next one, I want you to pull out your cross product formula. What is CH cross CA? By cross product formula, this is what has happened. This is your cross product formula. Can accept? Nothing new, I'm just pulling out the formula that cannot be proven. I tell you, just use. Okay, so this is a cross product formula. Next, what I need you to do is look at this sine theta. Can I substitute sine theta as HP over CH? Can. What will happen to your equation? What will happen to your equation? Certain things will cancel off. Agree? Your CH will cancel off, right? And this is what you have left. Make sense? Okay? So now, focus on this. CA and CA. It's unit vector, right? So, HP will be H cross A hat. Okay, the length of HP is equals to H cross A hat. What I want you to do now is, can you flip back to your cross product on your projection? Your dot product on your projection. Can you look at page? I think it's page 9. You have this formula, H dot A hat. F in the bracket, in the box down there, you have a H dot A hat, and down here you have a H cross A hat. What is this thing? What is this? Chapter 2. This is your length of projection. What is this? The length of the opposite. So let's reference back to the same diagram. Okay? If I do dot product H dot A hat, what length do I get? CP. If I do cross product H cross A hat, I get the length of HP. The formula looks almost the same. One is dot, one is cross. Okay, so this is why I keep telling you, when you're writing down your solutions in your answer script, make sure it's clear to yourself whether it is a dot or it's a cross. The meaning is totally different. The formula looks exactly the same, the proof also the same, but this is when things can get confusing for you. And okay, one last piece of advice before I let you go. Please, when I ask you to do a sketch, usually I will ask you to sketch this diagram. If you flip throughout the subsequent section of the lecture notes, you will see my sketch always like that. Why I do that? Because I want you to recall the same diagram. When you draw this diagram, it's easy to remember all your formulas. Okay? So this is how you should be doing your sketch. Okay? So I'll stop here today. Next lesson, I will continue with the rest.